The solar system feels like a diagram we memorized as children, a bright lamp in the center, 8 planets in clean, obedient lanes, everything neatly arranged like marbles on a table. And if you stare at that picture long enough, your mind quietly adds something it was trained to trust on Earth, a sense of direction. Up, down, above, below. But space does not agree. On Earth, down is a promise written into your bones. Gravity pulls you toward a center, the ground answers your feet, the sky keeps its distance above your head. You can close your eyes and still know which way is which. Yet the moment you leave the planet, that certainty dissolves. There is no cosmic floor, no universal north, no absolute sky. 2 astronauts can float face to face, one upside down to the other, and neither of them is wrong. They're only oriented differently inside the same indifferent void. So when we ask what lies above and below the solar system, we're already admitting something strange. We're borrowing Earth language to describe a place that has no preferred orientation at all. And still there is a reference, not because the universe demands it, but because our solar system remembers how it was born. Billions of years ago, the sun ignited from a rotating cloud of gas and dust. Rotation flattened that cloud into a disk, a spinning sheet where matter collided, clumped, and grew grain by grain into worlds. The planets inherited that disk like a family trait. They orbit in a shared plane, almost aligned like cars on a racetrack. We call that plane the ecliptic. We treat it like a map's horizon, the closest thing the solar system has to level. But even that order contains a tremor. Mercury tilts by about 7 degrees, as if it never fully agreed to the rules. Pluto, dwarf planet, exile relic, leans harder, nearly 17 degrees. And then there are comets, ice, and darkness with ancient trajectories that slash through the system at wild angles, indifferent to our tidy plane plunging in like needles through a vinyl record. Which brings us back to the question now sharper, now more unsettling. If the planets live inside a disk, what surrounds that disk, above and below the ecliptic, isn't empty, it isn't nothing. It's the hidden architecture of our cosmic home, layers of frozen debris, solar breath, interstellar fog, and ancient explosions, structures so vast that the entire history of humanity has unfolded deep inside them without us ever seeing the tests. Walls. To understand what surrounds our planetary plane, we have to start with the inheritance, because the solar system did not form as a scattered collection of objects. It formed as a spinning event. A cold, diffuse cloud collapses under gravity. As it shrinks, it spins faster, conserving angular momentum like a skater pulling in their arms. Heat builds, pressure rises. At the center, the sun ignites. Around it, the remaining material flattens into a protoplanetary disk, dust, gas, and countless collisions. This disk is why the planets orbit in roughly the same direction and within roughly the same plane. Not perfect alignment, but a shared origin. A memory preserved in motion. That plane, the ecliptic, feels like order, but it's only order on average. Each planet carries a slight tilt, a small disagreement with the ancestral disk. Those inclinations are the fingerprints of early chaos, gravitational nudges, resonances, migrations, impacts. Even the flatness of the solar system is a scarred flatness stabilized over billions of years, but never truly pristine. And then you notice what doesn't fit. Comets. Some of them skim in close loop around the sun and return on schedules humans can measure decades, centuries. But the long-period comets are different. They arrive like messages from a time before the planets finished forming. Their orbits can be wildly inclined, even nearly perpendicular to the ecliptic. They don't just travel within the planetary racetrack, they pierce it. They fall inward from all directions, as if the solar system is being approached by visitors from a spherical frontier. That spherical frontier is where above and below becomes more than metaphor. Because beyond the neat planet zone, the disk thins into the Kuiper belt, a distant ring of icy bodies. And then farther still, the gravitational influence of the sun extends into something far stranger, not a disk at all, but a halo. A vast three-dimensional reservoir of frozen debris, trillions of objects, small and dark, mostly water ice, mixed with ammonia and methane. Relics of planet building that were scattered outward when the giant planets grew powerful enough to throw things away. Jupiter and Saturn especially acted like gravitational slingshots. In the early solar system, they didn't just shape orbits, they expelled material. Some fragments escaped the sun, entirely flung into interstellar space. Others didn't quite make it out. They were stranded in immense orbits so distant and slow that a single revolution can take thousands, even millions of years. And here's the haunting part. If those objects are really out there, they surround us in every direction. Not like a ring, like a sphere, a bubble of ancient ice so large that the idea of above and below starts to feel inadequate, as if we're asking which way is up inside an ocean. We give that bubble a name, almost casually, as if naming it makes it smaller. The Oort Cloud, a structure so enormous that its outer edge may reach 50,000, even 100,000 astronomical units from the Sunday, tens of thousands of times farther than Earth's orbit, far enough that the Sun is no longer the only sculptor of trajectories, far enough that the galaxy itself begins to tug. At that distance, sunlight is not warmth. It is a faint suggestion. A star reduced to a bright point that cannot feed you, cannot protect you, cannot even properly illuminate you. If you stood on one of those frozen fragments, if stood still meant anything, you would not feel like you were in the solar system at all, and yet you would be inside its oldest boundary. The Oort Cloud is believed to surround the Sun in a roughly spherical shell, a halo of relics left over from formation. But here is the catch, the uncomfortable scientific honesty at the heart of this story. We have never seen it, not directly. No telescope has resolved the Oort Cloud as a visible swarm. No probe has crossed it and sent back a map. It remains a hypothesis, a model that survives because the universe keeps handing us clues. Those clues arrive as comets. Long-period comets don't come only from the plane of the planets. They come from everywhere. Their orbits suggest a source region that is not flat like the Kuiper Belt, but isotropic, distributed across the sky. Some dive in from above the ecliptic, some from below, some from directions that make our tidy solar system diagrams look like lies. That pattern is hard to explain unless there is a reservoir surrounding us in all directions, a distant storehouse that can be disturbed. And disturbed it is. Passing stars over millions of years drift close enough to the Sun to tug gently at these icy bodies, reshaping their orbits. The slow gravitational tide of the Milky Way itself can nudge them like a hand stirring the surface of a dark pond. Most remain locked in their remote paths, frozen and forgotten. But some are tipped just slightly onto new trajectories, falling inward toward the Sun, toward the planets, toward us. When one arrives, it feels sudden. A bright tail. A spectacle in our skies. But it is not sudden at all. It is the end of a journey that began when mammals were still small, when continents were different, when our species did not exist. A comet is time made visible, an ancient fragment thawing briefly in sunlight, then escaping again or shattering or vanishing into the dark. So, above and below the solar system isn't empty space. It is a cemetery of building blocks, a spherical archive of what we were made from. And still, that is only the first layer. Because even as we drift inside this halo of ice, the Sun itself is doing something more active, more continuous, breathing outward, filling the void with a storm that never truly stops. The Sun is not only a source of light, it is a machine that throws itself into space. Every second, it releases a flow of charged particles, electrons, and protons streaming outward in all directions. The solar wind. It is invisible to your eyes, but not to matter. It pushes, it sculpts, it carries the Sun's magnetic field outward, like threads pulled into the dark. Over enormous distances, that wind inflates a bubble around the entire solar system, the Heliosphere. If the Oort Cloud is the fossil halo, the Heliosphere is the living skin. It's our star's atmosphere stretched to planetary scale, a protective envelope that deflects much of the cosmic radiation and charged particles drifting in from the galaxy. We live inside it the way a diver lives inside, a suit protected, but never fully separated from what surrounds. And like any bubble pushed through a fluid, it isn't perfectly round. Because the solar system is moving, we are not parked in the Milky Way. We are in motion, sweeping around the galactic center at roughly 800,000 kilometers per hour. The Sun, the planets, the comets, the distant ice, all of it is a single gravitational craft crossing a sea of interstellar gas and dust. So the heliosphere is compressed on the side, facing our motion, and stretched out behind, forming a distorted teardrop shape, like the bow wave of a ship, like a wake trailing into darkness. There is a frontier where the solar wind begins to lose the argument. Far from the sun, the wind slows as it encounters the interstellar medium. The pressure of the galaxy pushes back. Eventually, you reach a boundary where the sun's influence fades into something else. A border with no fence, no wall, just physics changing its rules. The Heliopause. Cross it, and you are no longer in the sun's domain. You are in interstellar space, the cold, thin material between stars, threaded with magnetic fields, sprinkled with dust, and haunted by the radiation of ancient events. This isn't theory in the abstract. 2 human-built machines have approached that boundary. Voyager 1 and Voyager 2, launched in the 1,970 seconds older than many of the people listening now, have traveled so far that their signals take many hours to reach Earth. When they crossed into interstellar space, they didn't send back images of a gate. They sent data, subtle shifts in particle density and magnetic behavior, the faint signatures of leaving the solar bubble. And even beyond that boundary, we are not drifting through nothing. The sun is currently passing through a region known as the local interstellar cloud, a slightly denser patch of gas and dust within the larger cavity around us. Our heliosphere presses into it, interacts with it, reshapes itself against it, which means the space above and below our planetary plane is not empty altitude. It is environment. It is weather. It is the galaxy touching the edge of our star's breath. And if you keep going, if you pull back even farther, you find that our entire system is traveling through a region of space that seems strangely carved out. A room, a void, a bubble made by violence. The local bubble is one of those names that sounds harmless, almost cozy, until you understand the scale it implies. A bubble, not meters wide, not millions of kilometers wide, but roughly 300 light-years across. A cavity in the interstellar medium where the density of gas is far lower than average. A region of space that feels hollow. Astronomers suspect it was excavated by catastrophe. Millions of years ago, multiple supernovae detonated in our broader neighborhood stars, ending their lives with such force that their shock waves pushed surrounding gas and dust outward, sweeping it away like smoke from an explosion. Over time, those overlapping blasts could have carved a vast cavity, a low-density chamber in the galaxy, expanding, cooling, and slowly settling into a strange quiet. And the most unsettling detail is that this bubble has edges, walls. At the boundaries of the local bubble, the displaced material piles up into denser regions, filaments and clouds, where gas and dust accumulate like the rim of a cosmic crater. It's as if the solar system is sailing inside an interstellar room, and far away beyond the reach of any human lifetime, the walls are thicker, colder, and brighter in radio and X-ray whispers. Now imagine what that means for the future. The solar system does not stay inside one environment forever. As we orbit the Milky Way, we drift through different regions, clouds of varying density pockets, shaped by old explosions, streams of material flowing along magnetic fields. The heliosphere changes shape in response, compressing or expanding depending on the pressure outside. The flux of cosmic rays reaching the inner solar system can rise or fall. Interstellar dust, drifting inward, can subtly alter what our instruments measure, what our skies contain, even how the boundary of our star's influence behaves. This is why above and below matters to scientists in a deeper way than geometry. By mapping how gas, dust, and stars are distributed relative to the galactic plane, by tracking how these structures warp, ripple, and rise, astronomers can reconstruct a history of star formation and death. Supernova after supernova carving cavities, triggering new stellar nurseries at the edges, and within those motions may be clues to something we still cannot see directly: the gravitational scaffolding of dark matter shaping the Milky Way's halo. So the solar system isn't drifting through emptiness. It's traveling through a layered aftermath, through rooms made by dead stars, through currents of gas, through invisible pressures that sculpt our star's protective skin. And then the thought lands quietly but heavily. If our local neighborhood has walls, what kind of structure does the entire galaxy live inside? Look at the Milky Way. In your mind, the way you've been taught, to a shining disk, a graceful spiral, a flat pinwheel of stars. It's a useful picture. It's also incomplete, because even the galaxy refuses to stay in a single plane. It has a central bulge swollen with stars, spiral arms that are not rigid beams but flowing patterns rearranged over time, outer regions that appear warped edges that curve and bend as if the disk has been gently twisted by gravitational encounters or by the slow asymmetry of the cosmic neighborhood. And above and below that luminous disk is something even stranger, the galactic halo, a roughly spherical domain extending far beyond the bright spiral arms populated by older stars, globular clusters, and a gravitational presence we can feel but cannot see. If dark matter exists as we suspect, much of it may live in this halo, an invisible mass shaping the motions of the stars, binding the galaxy together like a hidden skeleton. So, the pattern repeats: a disk inside a sphere, a bright plane inside a vast envelope, a familiar map floating inside a deeper truth. And here finally is the paradox that should make you feel that gentle dizziness, that cosmic vertigo. Up and down are not features of the universe, they're survival tools. On Earth, direction is enforced by gravity and ground. Your body evolved to trust that enforcement so completely, you never question it. But the solar system is not a floor with a ceiling. It's a moving geometry, a rotating memory of collapse, surrounded by halos, shells, bubbles, and boundaries that have nothing to do with human intuition. We draw the planets lined up like beads and call it understanding. In reality, we are living deep inside a cathedral of invisible structures, a spherical cloud of ancient ice surrounding us, like a fossil atmosphere, a heliosphere inflated by the sun's constant storm, interstellar clouds brushing against that boundary, and a vast local bubble, an interstellar room hollowed out by supernovae that exploded long before the first human looked up. And still, against all of that scale, against all of that indifference, something happened. On one small planet inside one thin orbital plane, chemistry learned to remember itself. Matter arranged into cells. Cells learned to see. Eyes learned to interpret faint starlight and call it beauty. A fragile oasis woke up inside a moving ship, inside a bubble, inside a cavity carved by dead stars, inside a galaxy wrapped in unseen mass. That is what above and below really reveals. Not just where the solar system sits, but how exposed, how embedded, how unbelievably contingent our existence is. The night sky is not a ceiling. It is depth in every direction. And we are drifting through it together, carried by a star's gravity and a universe that never once promised to make sense.